Example 2, the scores of an economics examination are normally distributed with a mean of 72 and a standard deviation of 16. If the instructor assigns a grade of A to 10% of the class, what is the lowest score a student may have and still obtain an A? So this one's a little different because here they're essentially giving us the probability that we would need to calculate, and they're asking us to find the score, the X value, ultimately. So basically, I'm going to work my way backwards from a probability to a z-score, and then from the z-score to a score. So I'm still going to use the fact that the mean was 72 and the standard deviation was 16. I'm going to be looking at a normal distribution, and I want 10% of the scores to be A. So anything in this region to the right of this score here, whatever it is going to be my A's. Which means that, since I'm doing this because the table always deals with areas to the left, that means that 90% I expect to be below this score. So I'm actually looking for the fact that the probability that Z is less than some value A, which gives me about 0.9. Now this one's a little bit more tricky because I got to try to figure out what this A value is. I got to figure this particular Z score. That's what A is going to be. So I got to kind of work my way backwards on the table. And since I know it's going to be above the average, I'm going to look in the positive table side. And so, whichever is where I am right now. And what I'm looking for is to find a score that is closest to 0.9. So if I look down here, that's 0.9032, a little big. This is closer, 0.9015, still a bit over. This is a bit under at 0.8997. This is 0.003 under. This is 0.15 over. This one here, the 0.8997, is the closest to 0.9. If I can find it exactly, great, but sometimes you're not going to be able to. So when I look at the score here, this is 1.28. So the z-score that has an area to the left of about 0.9 is 1.28. So I make note of that. It's about 1.28. And that's my z-score. That's my particular z-score here. So if I was doing a z distribution down here, this would be 0, of course, and this would be 1.28 approximately. So I'm going to calculate the score minus the mean over the standard deviation should be about 1.28. So I multiply both sides by 16 and then add 72. I get 92.48. So right here is 92.48%, or whatever the score of 100 is. I want to make sure that I have that score, to make sure the lowest score, to make sure I have an A. So I want to be over that. So it'd probably be best for me to say I have a 93% to put me definitely in that range. So I would like to say that to have an A, a 93% score or more is needed for this circumstance.